Determine whether the integral is convergent or divergent, and evaluate if convergent. The integral from negative infinity to 0, 1 over 3 minus 4x dx. Here we have an improper integral. We can see that pretty quickly because we have a negative infinity here as a limit of integration. So we have to use the definition to evaluate this limit. This integral. The integral will be equal to the limit as a approaches negative infinity. The integral from a to 0, 1 over 3 minus 4x dx. This integral then is an integral that the fundamental theorem of calculus will allow us to evaluate, and then we can take the limit and see if the improper integral actually converges or diverges this integral. So let's take our definite integral and we'll take it over here and evaluate it, and then we can apply the limit. So we have the integral from a to 0, 1 over 3 minus 4x dx. So we can let u be equal to 3 minus 4x. du is negative 4 dx. So notice here we need to multiply by a factor of negative 4 in the numerator, which means we need to divide by negative 4 outside of the integral. Substitution. So this turns into negative 1/4. The integral on the new limits of integration, whatever they may be, 1 over u du. We know that the integral 1 over u du is the natural log absolute value of u. And we are evaluating at those new limits of integration. Now, u is equal to 3 minus 4x. Once we get back to x's, we can evaluate it at our original limits of integration, a to 0. So this goes over here. We have the limit a approaches negative infinity of negative 1/4 the natural log absolute value of 3 minus 4x evaluated on the interval from a to 0. Fundamental theorem says once we find that antiderivative, first we plug in the upper limit of integration, which in this case is 0, so negative 1/4 natural log absolute value of 3 minus 4 times 0 minus, then you plug in the lower limit of integration, which for this integral is a. Okay, so this becomes the limit as a approaches negative infinity, negative 1/4 the natural log absolute value of 3 plus 1/4 the natural log absolute value of 3 minus 4 times a. Of course, the limit of negative 1/4 natural log absolute value of 3 is just going to be that. It's a constant. So negative 1/4 natural log absolute value of 3, and technically we don't even need the absolute values. 3 is already positive. As we take the look at the limit of 1/4 natural log of 3 minus 4a, notice that a is getting very, very large in the negative direction. When you multiply that by negative 4, that's getting very large in the positive direction. Add 3, it's even larger. So this part is getting closer to infinity. And we know that the natural log, as the input of the natural log gets closer to infinity, the natural log actually also goes to infinity. So this whole thing goes to infinity. And as this whole thing gets very, very large, dividing by 4 really doesn't affect the thing. This whole quantity is going to tend to infinity. So it's going to be plus infinity. If you take infinity and add negative 1/4 natural log of 3, you're still going to wind up with infinity. So this limit is infinite, which means that it diverges, and that tells us that the integral diverges. You could say so. The integral from negative infinity to 0, 1 over 3 minus 4x dx diverges.